Alon Amit wrote, all chess sets in the world are isomorphic. Even the online ones. Even the ones in the magazine. Even the one you keep in your mind as you play a blind game. The black king in any set can be matched with the black king in any other set, and they obey the same rules and make the same moves. Any game can be played on any set. Many mathematical structures consist of elements, numbers, points, functions, what have you, and various connections or relations or operations between them. Things can be added, or multiplied, or compared, or have a distance between them. The essence of the structure, like the essence of chess, emerges from those connections, or relations, or rules. The physical form or abstract nature of the elements are immaterial. If you have two structures of the same kind, two fields, two groups, two topological spaces, and their elements can be matched up in a way that preserves the rules, we say that they are isomorphic. Isomorphic comes from equal shape or equal form. All monads are isomorphic. In relation to being, they are all playing exactly the same game, every monad perfectly coordinated with every other monad. But all monads evolve differently in the domain of becoming. They all play their own individual game, albeit within a single overarching collective game. Their localized space-time environment becomes decisive and they all become asymmetric in relation to each other. At zero entropy, this asymmetry disappears and all monads become perfectly symmetrical. Max Tegmark wrote, "Let us now digest the idea that the physical world is a mathematical structure. Although traditionally taken for granted by many theoretical physicists, this is a deep and far-reaching notion." This is an interesting comment. Many theoretical physicists are indeed quite receptive to mathematical reality, and yet they are not nearly receptive enough, so they end up in a hopeless no-man's land where they promote staggeringly mathematical theories such as M-theory, while absolutely refusing to accept analytic mathematical entities such as sinusoids as the foundation of existence. Instead, they talk about bizarre one-dimensional strings. These might be regarded as the most dismal compromise between matter and mathematics. They are neither one thing nor the other. Tegmark wrote, "It means that mathematical equations describe not merely some limited aspects of the physical world, but all aspects of it. It means that there is some mathematical structure that is what mathematicians call isomorphic, and hence equivalent, to our physical world, with each physical entity having a unique counterpart in the mathematical structure and vice versa. Why talk about a mathematical reality isomorphic to a physical reality? There is only a mathematical reality, and this is misinterpreted by scientists as a physical reality, because scientists refuse to accept the ontology of mathematics." Tegmark doesn't accept that mathematics is actually mental, not physical. Scott Aronson wrote, "It seems fair to say that the physical world is isomorphic to a mathematical structure, and moreover, a structure whose time evolution obeys simple, elegant laws. All of this I find unobjectionable, but Tegmark goes further. He doesn't say that the universe is isomorphic to a mathematical structure, he says that it is that structure, that its physical and mathematical existence are the same thing. It's impossible for physical reality to be isomorphic with mathematics if physical reality is real and mathematics is unreal. If the reality of mathematics is accepted, then it's impossible for there to be two ontologically different systems, the physical and the mathematical, which are isomorphic and yet completely different. If they are isomorphic, they are the same." It's amazing how often scientists flirt with Cartesian substance dualism. Physics is not one substance and mathematics another completely different substance that somehow miraculously interacts with, or accurately models, physics. Rather, there is only one substance, mathematics, which humans interpret, or misinterpret, as physical. Physical is a man-made label, reflecting how unable humans are to perceive the world as mathematical. Paul Austin Murphy wrote, "One part of Tegmark's argument is that if a mathematical structure is identical, or equivalent, to the physical structure it models, then they're one and the same thing. Thus, if that's the case, that structure X and structure Y are identical, then it makes little sense to say that X models, or is isomorphic with, y, that is, x can't model y if x and y are one and the same thing. Tegmark applies what he deems to be true about the isomorphism of two mathematical structures to the isomorphism between a mathematical structure and a physical structure. He gives an explicit example: electric field strength equals a mathematical structure. Or in Tegmark's words, if this electricity field strength here in physical space corresponds to this number in the mathematical structure, for example, then our external physical reality meets the definition of being a mathematical structure, indeed, that same mathematical structure. In terms of Leibniz's law, that must also mean that everything true of X must also be true of Y. But can we observe, taste, kick, etc. mathematical structures? Notice how baffled Murphy is by the notion of the ontology of mathematics. He commits the argument from incredulity. Wikipedia says, argument from incredulity, also known as argument from personal incredulity, appeal to common sense, or the divine fallacy, is a fallacy in informal logic. It asserts that a proposition must be false because it contradicts one's personal expectations or beliefs, or is difficult to imagine. When it comes to mathematics, virtually all of the world adopts the argument from incredulity. It's every bit as pernicious as the argument from authority, which is also extremely popular in science. Murphy believes, no doubt, in quantum mechanical wave functions, because science told him to, and he swears by the authority of science. But what are these? According to science, they are unreal abstractions that collapse into specific real things and events. Would Murphy like to explain how unreal things become real? What exactly is reality for Murphy? If atoms are quantum mechanical systems, are they real or unreal, concrete or abstract? Simple-minded people such as Murphy believe in solid matter, like the solid little lumps of the ancient Greek atomists. But no such things exist. By science's own account, modern atoms are almost entirely empty space, and any properties they possess are entirely defined through mathematical means. So what exactly does Murphy mean when he doubts that we can observe, taste or kick mathematical structures? That's what atoms are. They can have no other definable meaning. It's the mathematical properties of things that are misperceived by naive individuals such as Murphy as the physical properties of things. What are physical properties? Go on, define them without making any reference to mathematics. Good luck with that. Physics certainly can't do it. Physics is in many ways even more mathematical than mathematics itself. It's an endless exploration of man-made, abstract mathematics, while trying its best to ignore concrete Occam's razor mathematics, i.e., ontological mathematics. Murphy, like so many apologists for scientism, is just a new version of Samuel Johnson, with his infantile response to the sophisticated immaterialism of Bishop Berkeley. All such people commit the fallacy known as the appeal to the stone. Wikipedia says, appeal to the stone, also known as argumentum ad lapidem, is a logical fallacy that dismisses an argument as untrue or absurd and proves this assertion by stating that the argument is absurd. This theory is closely tied to proof by assertion due to the lack of evidence behind the statement and its attempt to persuade without providing any evidence. Appeal to the stone is a type of informal fallacy within the realm of logical fallacies. This means that appeal to the stone relies on inductive reasoning in an argument to justify an assertion. The assertion relies entirely on the content of the argument and does not examine the form or structure of it. The name appeal to the stone spawned from an argument between Dr. Samuel Johnson and James Boswell over George Berkeley's theory of subjective idealism, known previously as immaterialism. Subjective idealism states that reality is dependent on a person's perceptions of the world and that material objects are intertwined with one's perceptions of these material objects. Johnson rejected Berkeley's argument that material things only exist in one's own interpretation by striking his foot against a large stone and stated, "I refute it thus." Johnson's argument of appeal to the stone was to disprove subjective idealism by showing that by striking his foot against a large stone and observing his foot rebound off of it, would prove the laws of subjective idealism were incorrect. Just as Johnson didn't understand the first thing about what Berkeley was arguing, kicking a stone does not disprove anything at all regarding Berkeley's system, neither does Murphy understand the first thing about Tegmark's system. He literally cannot escape his personal, subjective, irrational incredulity regarding the ontology of mathematics. He can't imagine such a thing, so immediately looks for ways to attack any such notion. It never occurs to these people to attack their own belief systems and look for reasons to accept the new ideas. That's not how they roll. Their objective is always to shoot down the new and defend the old. They are always conservative in attitude. This is precisely why paradigm shifts are so difficult, and why Max Planck said that science progresses funeral by funeral. You have to wait for dinosaur thinkers like Murphy to die before you can make intellectual progress. These people always resist to the last read out every great new idea. They would never take the side of radical new thinking. Wikipedia says, Tegmark's propositions raise one basic question: can one make precise sense of a notion of isomorphism, rather than hand-waving correspondence, between the universe, the concrete world of stuff and events, on the one hand, and mathematical structures as they are understood by mathematicians, within mathematics? Unless, or optimistically, until, this is achieved, the often heard proposition that the world/universe is mathematical may be nothing but a category mistake. The Greek term iso can mean similar or identical. Max Tegmark isn't arguing for weak isomorphism, i.e., mathematical structures have a relationship, a similarity, a correlation or correspondence to physical structures but are not the same, but for strong isomorphism, i.e., mathematical structures are physical structures, they are identical.